In this video, we're going to have a look at calculating molecular formula. So if you have your booklet open at page 6, that's where we're going to be starting today. But just a quick reminder before we look at these calculations, just a reminder of the difference between empirical formula and molecular formula. So if you remember from our last lesson, the empirical formula represents a formula which shows the simplest whole number ratio of atoms of each element in a compound. So that's one where we cancel it down essentially to the simplest whole number ratio. And that's what we've been calculating so far, is the empirical formula. But today we're going to be looking at the molecular formula, which is a formula which shows the actual number of atoms of each element in a molecule. So last lesson we looked at an example of ethane. So ethane has the molecular formula of C2H6. That would be the molecular formula because it actually has 2 carbon atoms and actually has 6 hydrogen atoms. But if we were to have a look at the empirical formula, it would be CH3 because that's the simplest whole number ratio, because we can divide both of those atom numbers by 2. And that would give us an empirical formula of CH3. So let's have a look at the bottom of page 6. So in these types of questions, you may be given the empirical formula and the molecular mass of the molecule, or you may be just given the information as we were in our previous lesson, and in which case you would have to first of all calculate the empirical formula. As I said, sometimes you are given that already. Second step then is to calculate the empirical formula mass. What we mean by that is essentially the RFM of the empirical formula. What we then do is calculate the ratio of the molar mass of the molecular formula to the empirical formula mass, because the molecular formula is simply going to be a multiple of our empirical formula. So if we look at that example of ethane again, as I've just written it up at the top of the page, the molecular formula is simply twice the empirical formula. There are twice as many carbon atoms and there's twice as many hydrogen atoms, which means the RFM should be twice as much as the empirical formula. But let's see if that's true. So for the empirical formula, we have 1 atom of carbon, which has a relative atomic mass of 12. And we have 3 hydrogen atoms, so that would be a total mass of 3. So that gives us a relative formula mass of 15 for our empirical formula. So that would be what we call the empirical formula mass. Let's do the same for the molecular formula. So this time we have 2 carbon atoms, so that's going to be 12 times by 2, which is 24. And we have 6 hydrogen atoms, which is a total mass of 6. 24 plus 6 is equal to 30. So you can see that our empirical formula has a mass of half that of the molecular formula. So if I was to calculate the ratio of the molar mass of the molecular formula to the empirical formula mass, I would essentially be doing 30 divided by 15, which is 2. And that's what we mean by the ratio of molar mass of molecular formula to the empirical formula mass in step number 3. And then what we do is we multiply everything in the empirical formula by this number. So if it was our example of ethane and we didn't know the molecular formula, we were just given that molecular formula mass, we would be saying, okay, well, my empirical formula is CH3, my ratio is 2, and so my molecular formula is going to be C2 because there was 1 carbon and now there's 2, and H6 because I had 3 multiplied by 2, which is 6. Let's look at a worked example of that. So over on page 7, have a look at worked example 1. It says the empirical formula of a compound is CH. So in this example, I have been given the empirical formula, so I can skip by step number 1. The molar mass is 78 grams per mole. What is the molecular formula of the compound? So the empirical formula is CH. What is the empirical formula mass? So we're looking for essentially what is the RFM of the empirical formula. So we have got 1 carbon, which is 12, plus 1 hydrogen, which is 1. So that gives me an empirical formula mass of 13. So that would essentially be 13 grams per mole. That's the unit for molar mass. Essentially, it's the RFM in grams per mole, because that's essentially what RFM is. If we thought about what is the RFM of water, it's 2 plus 16, which is 18. So what does that really mean? Well, it means that 1 mole of water would be equal to 18 grams. It would have a mass of 18 grams. So we could say that water has a molar mass of 18 grams per mole. That's just all that unit means. Okay, so then we're asked for the molar mass, and really what it's saying here is the mass of the molecular formula. And for this, simply think, well, what is the definition of molecular formula? It's the formula that represents the actual number of atoms within the formula of a compound, so that will give us the molar mass of the compound. And we're told in the question that that is 78 grams per mole, and you'll always be told that in the question. So now we're on to step number 3, which is calculate the ratio of molar mass of the molecular formula to the empirical formula mass. So essentially what we're doing here is we're taking the molar mass of our molecular formula. I just abbreviated that down to MF, but if you need to write in what that means, then please do. Divided by the molar mass of the empirical formula. I've just abbreviated that to EF. And that will essentially give us the multiple of how much bigger the molecular formula is compared to the empirical formula. So to do this, I'm simply taking my molar mass, or my RFM, of the molecular formula, which we're told is 78. You can include your units if you wish, but they're just going to cancel out, grams per mole and grams per mole. So that's going to be 78 divided by our empirical formula mass, which is 13. If you put that into your calculator, 78 divided by 13 gives you a ratio of 6. So there are 6 times as many atoms in the molecular formula than there are in the empirical formula. So we're on to step number 4 now, and please keep those steps open in front of you if you need to when you're doing these questions. The last step is to multiply everything in the empirical formula by this ratio number, because again we know the molecular formula is 6 times bigger than the empirical formula. So for this I'm doing, well, my empirical formula is CH multiplied by 6, so that means for each of your atoms you multiply that number by 6. So we had 1 carbon atom, now we're going to have 6. We had 1 hydrogen atom, and now we have 6. So that is your final answer. Your molecular formula is C6H6. Let's have a look at worked example 2 now, and this is a type of question where you need to do step 1 as well. So we need to calculate the empirical formula and then calculate our ratio to work out the molecular formula. So this is back to what we were doing in our last lesson. So we're told that an analysis of ethene shows that it contains 86% carbon and 14% hydrogen. Given that the molar mass is 28 grams per mole, find the formula of ethene. So we're given our percentage of our elements. So from that, we're going to calculate our empirical formula. And we know that our molar mass, which represents the mass of the molecular formula, is 28 grams per mole. So you could annotate that if you wish. So let's work out our empirical formula first, which is step 1 of our method. So we know that we have got carbon and hydrogen. So what we need to do is work out the mole ratio of these elements. Remember that where you're given a percentage, you can just assume that's the percentage by mass. So let's assume that we have 100 grams of our substance. That will mean that there's 86 grams of carbon, and you don't need your unit because your unit's at the side there in the table. But you can put it in if you wish. If you weren't setting this out as a table, you would need to. And then you have 14 grams of hydrogen. The RFM of carbon is 12. The RFM of hydrogen is 1. Then we need to calculate the number of moles by using N equals mass over RFM, because remember, we can't just put the masses in ratio to each other. So for carbon, it's going to be 86 divided by 12. Which gives us 7.16 reoccurring. And then for hydrogen, it's going to be 14 divided by 1, which is obviously 14. Then we want to calculate our mole ratio, and remember for this we divide by the smallest number of moles. So we're going to be dividing by 7.16 reoccurring. If you put that into your calculator, so for carbon that's going to be 7.16 reoccurring divided by 7.16 reoccurring. That will obviously give us a mole ratio of 1 since we're dividing it by itself. Then for hydrogen, we're doing 14 divided by 7.16 reoccurring. That does work out as about 1.95, which we can then round to 2. You have to judge at this stage, is it something like, 1.5, which would mean we would need to multiply both by 2. But in this case, the number is close enough that we can just round it off to 2. So my empirical formula is CH2. So what I want to do now is calculate my molecular formula. Now I haven't left you much room at the bottom of the page here, so if you don't think you'll have enough room, then there's space at the bottom of the next page if you'd like to do it there. Apologies about that, but you can do a wee bit of working out down the side if you prefer to fit it all in just on page 7. So if you go back to our method from page 5, then essentially we have calculated the empirical formula. What we need to do now is calculate the empirical formula mass. So if we look at our empirical formula, it's just C1 essentially. So we have got 1 carbon, which has a mass of 12, 2 hydrogens, which will have a mass of 2, which gives us 14. Step number 3 is then to calculate the ratio of the molecular formula mass to the empirical formula mass. So we do that by taking our molar mass of our molecular formula and dividing by the molar mass of our empirical formula. So we were given the molar mass of the molecular formula in the question. So that is 28 grams per mole, and we are dividing by the molar mass of the empirical formula, which we've just worked out as 14. So 28 divided by 14 is 2. And then we're on step number 4, which is to calculate the molecular formula. We multiply everything in the empirical formula by that ratio. So the molecular formula is equal to CH2, which is our empirical formula, multiplied by our ratio, which is 2. So you're multiplying the number of each atom by 2. So that gives us C2, because we had 1 carbon, now we've got 2, and then H4, which is 2 multiplied by 2. So that's your final answer, C2H4. Okay, so what I'd like you to do now is to complete exercise 2. So complete it on file paper. As I said in the last lesson, just have a set of file pages at the back of this unit where you're doing all your exercises, so you can look back on them. Show all your working out. If you're not sure where to go with a question, please use the method on page 5 to help you. Be careful whether they're asking you for the empirical formula or the molecular formula. When you're finished, please mark your work using the answers in files on Teams. And then please submit photos of your marked work to the assignment on Teams. So mark it first and then upload photos. They don't have to be in a Word document unless you kind of want me to check them and see where you went wrong and write over them. Just photos are fine otherwise. I have also included a few extra questions in the instructions document for today. So if you want a little bit of extra practice in them, then you can have a go at those. But as long as you've done questions 1, 2 and 3 and submit them to the assignment on Teams, then that is fine.